parent functions. The objective of this video is to identify and graph and describe characteristics of parent functions. So a function family is basically a group of functions with similar characteristics. So the parent function is basically the simplest form of that family. Usually we are not including any of the operations in these parent functions. We are choosing to find the simplest input. So our first parent function is the linear function, which just means f of x is equal to the letter x. This produces a straight line straight through your origin. So the domain of this would be all real numbers, and the range will also be all real numbers. Another key features is we can describe the end behavior. So as x is approaching infinity, f of x is approaching infinity, and as f of x is approaching negative infinity, f of x is also approaching negative infinity. The second parent function would be the absolute value function, which means f of x is equal to absolute value bars x. Because we are taking the absolute value of any number, our output will always be positive numbers. So in that case, the domain can be all real numbers, but the range is limited to y is greater than or equal to 0, eliminating that negative factor. The quadratic function, denoted by f of x is equal to x squared, is another parent function which produces this parabola that we see in the image. The domain is all real numbers. However, the range is very similar to the absolute value function, where y is greater than or equal to 0 because taking the square of any negative number produces a positive output. The cubic function, x to the third power, we end up with this squiggly looking graph that hits all of my x and y's. So the domain is all real numbers and the range is all real numbers as well. Now the square root function, so f of x is equal to the square root of x. In this case, the domain is greater than or equal to 0 because remember, we cannot have any negatives inside the radical bar. And the range is all positive numbers because we have positive numbers to begin with. The last one, the reciprocal function. So that means f of x is equal to 1 over x. Now this function is a little special because some asymptotes are created by nature of this graph. So remember, when I have a fraction, there is one number that x can never be. X can never be 0. It could be any other number, it just can't be 0. Because the domain is all real numbers, however, x cannot be 0, then this causes a asymptote. So an asymptote is basically like an imaginary wall where the graph will never cross. The graph approaches this wall but never crosses it. That's why it looks like it's hitting 0, but if we were to zoom in on this graph using a graphing calculator or Desmos, you'll be able to see it never actually crosses 0. And if we were to make a table of this function, we can also see that. There are two walls, one at x equals 0 and one at y equals 0. So that means there's a vertical asymptote and a horizontal asymptote.